In this demo, I'm going to be describing how you can use the multiple PLP analyses function to do predictions for lots of different T's, lots of different O's, lots of different population settings, so that means your time at risks, lots of different models, like the classifiers you're going to be using, and lots of different covariate settings. So similar to before, I'm going to source my connection details from the file that I've saved. So the connection details, this script here contains the DBMS, the server, the port, the user, and the PW values that I have. I can't share these with you of the demo, so I'm just going to source them from here. And then you'll need a CDM database schema string. So this is the string that specifies where your CDM database schema is, or your database schema is. And here is, you need the cohort database schema, which is a string that tells you your cohort database schema. So this is the schema that contains the cohort tables that you're going to be using. I'm going to source them from here because, again, I can't share these. And then the next ones you'll see is that we have these outcome IDs and outcome names. So we've got outcome IDs because the multiple PLP analysis assumes that you're going to be running lots of T's and lots of O's. So you're going to have to input a vector of your outcome IDs. If you only have one outcome ID, you just simply put in the one value. But if you have more, you can put these all in separated. So if we had an outcome ID of 9 and an outcome ID of 8 that we also wanted to investigate, we could add them in here. And then we just have to put in the names in here. So for every outcome ID you have here in this vector, you need to have the name, a string specifying the name of that outcome ID as your outcome names vector. So 7921 cohort is suicidal thoughts and behaviors, and this is the outcome we're going to be predicting. Then you've got your cohort ID vector, which is, in this case, I've got 3 of them. So I'm going to be looking at 3 different target population cohorts, and I've got their cohort names here, which is the treated depression 7921, NSAID new users 7922, and initial atrial fibrillation 7617. So for every single one of these target cohorts, I'm going to be predicting this outcome ID. So we're going to have at least 3 different models. Now, I just want to point out, if you have an outcome ID that's the same as the cohort ID, so for example, if we had the 7920 here, and we wanted to have the treatment depression as an outcome as well, then when the multi-analysis runs, it actually does something smart where it looks to see whether your outcome and target cohort IDs are the same. And if they are, it won't run the model that's using a target cohort and outcome ID the same. So it will, if you have these values, as you're seeing here, with the 2 outcomes and the 3 targets, and one of the outcomes and the targets are the same, you'll actually be doing, in treated depression individuals who has suicidal thoughts and behaviors, in treated depression, you won't predict this, so you only have one model. And then in the NSAID, you'll be predicting suicidal thoughts and behaviors, and then you also have a model in NSAIDs predicting treated depression. And then for the initial atrial fibrillation cohort, you'll be predicting suicidal thoughts and behavior, and in the initial atrial fibrillation, you'll also be predicting treated depression. So the only one that's excluded is predicting treated depression in treated depression, because that just doesn't make sense. So I'm just going to remove these now to go back to the way we were. Then the connection details here will just be the values that get you set up to your database. And then the next new thing really that you need to consider is this covariate setting. So I'm going to show you here 2 different covariate settings. So in the covariate settings 1, I'm using the feature extraction, create covariate settings, and I've decided to use condition group error long term, and then age, gender, and I look back 1 year. And then in the second covariate settings, I'm going to look at drug exposure long term and look back 1 year. So covariate settings 1 is looking at conditions, covariate settings 2 is looking at drug exposure. And then I'm going to create a covariate settings list. So inside a list, I'm going to put in my covariate settings 1 and my covariate settings 2. If I'd have more covariate settings, I would just create them down here. So I could add in some more covariate settings here, and I would just simply append them onto this list here. So you can have as many covariate settings as you want. The model settings, here I'm going to show you an example of using 3 different models. So again, we've got this model list object, and then this is a list, and then inside the list we're going to have ADA boost, gradient boosting machine, and the lasso logistic regression. Because I've not put anything inside these functions, I'm going to be using the default hyperparameter search. But if you wanted to actually specify the hyperparameters you want to search, you can edit these inside these functions here. But this is just showing that for here we're going to train 3 different prediction models. We're going to consider 2 different covariate settings, and then finally we're going to look at 2 population settings. So we've got population setting 1 and population settings 2, where population setting 1 is going to look at a risk window start of 1 to 365 days, and so is population settings 2. It's going to have a required min time at risk of 364 days, and this one's the same. And a washout period of 365 days, but in the settings 1, we're including all outcomes, and the settings 2, we're not including all outcomes. So what this means that in setting 1, because we're including all outcomes, and we've said that you have to have a minimum time at risk of the whole time at risk period, the 364 days, if you leave the database 180 days after your cohort start date, you're not observed for the whole time at risk. But if you had the outcome at day 50, you're still included into the study population. However, if you left the database at 180 days after your cohort start date and you didn't have the outcome at any point prior to that, then you will be excluded from your study population. But in the second case, we're not including all outcomes. So even if you had the outcome at day 50 and then you left it at day 180, you'll be excluded. So you have to have the whole observation. Now, including all outcomes can be useful if you know that your outcome is rare, or the outcome is linked to death, which is likely to make you leave the database. But you could also add a bias by having all these include all outcomes, because if you include all outcomes, you're including people that have potentially died during the time at risk, but you've restricted it so that the people who don't have the outcome could have never died during the time at risk. So you might have sicker people, and that could cause a bias. So that's why I would actually always recommend doing both of these settings, and just to see what is the impact of including all the outcomes and not including all the outcomes, to see how stable the models are. And again, once you've got your model settings, you just put them inside a list, the population settings 1 and the population settings 2, and then you have this population setting list. So now we've defined a list of population settings, we've defined a list of model settings, we defined a list of covariate settings. We can now create a PLP model setting object. So here we use the PLP function, create PLP model setting. We add in our model list, a covariate list, and a population list. And this will then create our model analysis list. So this is now what we'll be putting into the run PLP analyses. And this basically tells you all the different combinations of the model, covariate, and population settings. And it will create a unique analysis ID for each of these setting combinations that will be used in the run PLP analyses. So now you can simply just run this function here, the run PLP analyses. You put in your connection details, you tell them what your database schema string is, you put in your CDM database name string. So this is just a friendly name for your database, because a lot of the time you might want to share your models, but you might not want people to know your CDM database schema. So instead, you can put in a nice name here that's shareable with other people. And again, you put in your cohort database schema string, you put in your outcome database schema string, which tend to be the same schema in this situation. You put in your cohort and outcome table. So here I'm just using the cohort table. And then you put in the output folder. So this is where, when you run this function, it's going to go through all the different T's, O's, and model settings that you have, and it's going to do the Cartesian product. So it's going to do a lot of models. And in this output folder, you're going to see, I'll show you later on after I've described this, you're going to see that you're going to have a structured folder where you've got your analysis IDs that will have your contain your models, and then you also have your PLP data and your populations. But it's done in a way where it will find combinations and things that are in common, so that you don't download the same data multiple times for different models. It will download the data once as needed. And then you have your model analysis list. So this is the one you just created here using the create PLP model settings. You have your cohort IDs that we did at the top with the cohort name vector, your outcome IDs with the outcome name vector, and then you've got this max sample size. So I've put 10,000 because I'm going to be demoing this and I don't want it to run forever, because I'm doing 3 T's, 1 O, 2 different population settings, 2 different covariate settings, and 3 different models. So I've got 3 times 2 times 2 times 3 different combinations of models. So there's quite a lot of models. I'm going to just sample. If you don't want to sample, if you've got plenty of time, just set this to null. The washout period, so this is saying that everyone in the PLP data object have to have at least 365 days prior observation. Minimum covariate fraction, so this is saying that at least 0.0001 fraction of people must have a covariate for it to be included. If it's less common than that, then it will just get removed. Normalized data, so whether you want to normalize, generally you do for things like lattice regression. For the tree base, it's not really going to make much of a difference. And then you've put in your test split and your test fractions. So I'm going to do the person split. Again, you could do a time split if you wanted. So person split just randomly assigns people to the test and train, but it keeps the proportion of how common the outcome is in the test train split. Whereas time split of a test split time will use the older data in the training and the newer data in the testing. Test fraction, so the fraction of your PLP data population that's going to be used to evaluate the model, and this is like the left out data that's not used to train. Your split seed, so I generally would recommend putting a split seed in this situation when you do your run PLP analyses, because that means that each of the models is going to have the same split. So if you're comparing across models, you want to make sure that they had the same split for the test and train, so it's actually more comparable. And then you've got your number of folds you're using in the cross-validation when you're picking your hyperparameters. So if you run this script now, it will start running through all the models, and it will then, once it's finished, you're going to have the file structure that I'm about to move over. I want to just point out that the run PLP analysis is made so that if you have some issue, so say for example there's some database issue and it stops the analyses after you've done 50 models out of 100 models you're going to do, it'll be very inconvenient if that made everything fail. So what we've actually got in place is that it will actually you can just rerun this code. If there's an error with something like a database connection failing, you can just set that connection back up again and then rerun this code, and rather than it start from scratch, it will start from where it finished before. So it will run through and see which models have actually been generated correctly, and if there's a model, saved model in the folder that it is expecting, then it will actually skip that. So it will actually find the bits that are missing and continue from there, rather than redoing everything. But this means that if you've made a mistake in anything, so say you've changed your cohorts and you want to rerun the analyses, then you need to actually either pick a different output folder or make sure that output folder is clear of anything that you want to rerun. Okay, so now I'm going to go over to the results to show you the results.